We are now going to see a procedure for restarting a solution. For the solution restart, it is important to have restart points generated during the previous solution. Therefore, appropriate settings in the restart control before the first solution are necessary. We have seen in detail how we can specify restart controls so that we can generate the restart points at the required intervals. We are going to see this with an example. Suppose that I am running a nonlinear analysis and facing solution difficulties. Before starting the first solution, I have specified the restart controls. As we can see, I am manually defining the restart point generation. I have requested a restart point at each load step, at 4 equally spaced points per load step. In order to limit the maximum number of restart files written, I am limiting the maximum number of points per load step to 3. I am keeping the restart files after the full solve, and combining the files, so that I will have the freedom to use different number of cores after the solution restart. Before the solution restart, it is good to check the solution output. This helps provide some important information on how the solution has been progressing. In the force convergence, we see that the first 4 substeps have converged, and the 5th substep has not converged. If we go to the analysis settings, we see an additional restart analysis table in the details window. We can see that the current restart type is set to manual, and the current restart point is set to initial. It is possible to set the restart type as manual, program controlled, or off. Note that, in the current restart point drop-down list, 3 points are shown. Initial, that is the start of the load step 1, substep 3, and load step 1, substep 4. Recall that I specified that the maximum 3 points should be saved per load step. The 3 substeps listed in the restart point drop-down list is consistent with my previous setting of maximum 3 points. The restart points corresponding to load step 1, substep 3 and 4 are shown in the dotted line in the graph window below. The initial or the start of the load step point is shown by 2 inverted blue triangles. The restart points and corresponding time is also shown in the table on right-hand side bottom of the Ansys mechanical window. Before restarting a solution, we need to review the model and make the required improvements, so that the finite element model will solve better. In this specific case, I see that the automatic time stepping is kept off, and the number of substeps is set to 10. I want to check if the solution converges better with the larger number of substeps. This will result in a more gradual load increment. Therefore, I change the number of substeps to 40. To keep things simple, I keep all the other settings and loads the same. Now, I go to the current restart point and select the most appropriate substep to restart the analysis. Although I can start from the last converged substep, it is often advisable to select a substep, at least a few substeps, before the last converged substep. Therefore, I choose load step 1 substep 3. This substep is previous to the last converged substep, that is, load step 1 substep 4. Selecting the initial step for the solution will start the solution all the way from the start of the first substep. Note that we are keeping the restart type as manual. If we set it to the program controlled, Ansys will select the most appropriate substep to restart the solution. After making the required changes in the FE model and choosing the appropriate substep for restart from the current restart point drop-down list, we simply solve the model.